Hello, I wanted to do a video because we are going to start offering this optic flow and Lidar sensor. Um, after talking to some recent customers, they're doing indoor competitions and having to hover in place and pick objects up and move them around. And so I felt like something like this potentially could be of assistance since it uses LiDAR and a range finding sensor to help with position hold when you're indoors when you don't have GPS available. One of our customers, Venus ISD, has actually already ordered some of these, so I wanted to do the video. If you go to our website and go to our accessories, you will find it listed in our accessories section. And there is a PDF file for setup instructions that will take you through all the steps to connect it up to your drone. At least software-wise. Now, the other reason that I wanted to make this video is we can send it to you. I am going to solder on 4 wires right here. Let's see, it does right here. So you see there's a TX, an RX, 5 volts and ground. So when I send these out, I will send out this with wires soldered to it. Whoever you are, will, when you get it, you will need to solder it onto the flight controller. Now, if you don't want to do that, if that's not something you're not soldering or your students aren't soldering, that's fine. The other option, if you wanted to utilize this particular accessory, would be you'd have to send your drones to me, to us, and then we would add them in and configure them and then send them back to you. So which would be an added fee, and I assume you guys might not want to send yours in. So again, that's why I wanted to make the video, was so that if you wanted to solder them into place yourself, you could. So this is what it looks like. These are where I will solder some wires. Now, the flight controller that we use for our iNav builds. This could be a Cobra, this could be a Hawk, or it potentially could be a Longbow. But this is the flight controller. There are 2 versions out. Actually, depending on how far back you go, there's actually been 3 versions, obviously, as you can see right there. This pictured is version 3. Here's a little bit bigger picture of it, of version 3. Version 2, if you look right here, you'll see that shows that it is version 2. I did not pull up version 1 because I don't think we've shipped any version 1 flight controllers. But all you got to do is Google Z's F7 flight controller, and it should bring you to these options. I'm going to go over the V3 because that's what most recently we have sent out. Now, why am I showing you this? So the optic flow sensor needs a TX, an RX, ground, and 5 volts. So we need to determine where we're going to pull our power from, which is more than likely going to be where your camera comes from. Because unless you have specifically requested a camera, most of you do not have them or did not get them. So what I would suggest would be to pull your 5 volts and your ground from these 2 pads right here. Why not something else? Why not some of the others? Well, this 5 volt and ground is for your GPS. So this one is going to be occupied. This 5 volt and ground is for your receiver. So this one also is going to be occupied. And then you may or may not have a video transmitter. That would be soldered in place here. And that also is going to have a 5-volt ground. So the one that should be available and open should be this guy here. Again, unless you're using a camera. If you are using your camera, if you don't have any of these options available, you could pull your 5 volts from the buzzer section over here, but instead of putting your ground on that, you could tie your ground in to any of these other grounds. They share a ground. The flight controller shares a common ground. So you could put it over here. Again, that's going to be the GPS. You could double lug it, as I call from being an electrician, but you could also land your ground on top of another ground. You wouldn't be able to use that one. You potentially could use here, but I think the LEDs, yeah, the LED pulls off of this. This may be open, but regardless, you're going to have to pull power from one of these sections. Okay. Now, the other thing you're going to need to do is the UART. So you'll see there is transmit and receive. And so you're going to have to find a transmit and receive that is available. Now, 4, transmit and receive 4 are being used by your receiver. The ESC actually I think uses 1. Does it show me up here? It does not, but I'm pretty sure that the ESC is using this UART1. So, more than likely, you are going to be adding your Lidar sensor to this T2R2. Now, the other thing to note is you need to change or swap. So, your TX wire is going to go to your R2 pad, or your RX. And then the RX here is going to go to the T, or the TX here. So that is how you will add it if you are going to solder it in place. Or like I said, option 2 is for you to ship your drone to me, and then, or to OnPoint, and then we will add it for you. If you have the older version 2, it's still pretty much going to be the same scenario. You're going to pull power from the cam section, because more than likely you're not using a camera. If you are using a camera and you cannot pull from there, you can pull from the buzzer one, use the 5 volt, and then land your ground anywhere that a ground is available. So once again, potentially there. I don't see a ground up in here anywhere. This one is going to be the GPS ground, but again, you could land it on top because the flight controller shares a common ground. So that would be where you would land your wires for your VBAT, or for your 5 volt and ground. Looks like T3 potentially, if you have the older V2, is going to be the better option, just because it's easier to get to. So that is what I would suggest if you are going to take on soldering it into place. And with that, I'm going to pause and move to one that I've already installed it onto. Okay, so I have hooked up the drone that I have our Lidar sensor wired up to, and I have connected up to the iNav configurator. So if you have gotten the Lidar sensor and you have wired it into place like we discussed in the first section of the video, then you probably are at this point now. So you're going to hook up to your computer, you're going to log into you're going to open up the iNav configurator. And the first place you are going to go to is ports, the ports tab. And wherever you wired the TX and RX, that's a UART. We talked about potentially doing it on UART2, I think, and then we talked about maybe using UART3, depending on what version of flight controller you have. But basically, this is where that information applies. So if you wired it onto UART2, then you would go and you would click this MSP. So you want to select MSP on the port that you wired it onto, and then the other thing you want to confirm is that the baud rate is showing 115/200. And then once you've made that, you're going to hit save and reboot. And once you come back into it, let's see, is it configuration? Yes, configuration. So the other thing you need to do is in the rangefinder and the optic flow section, you need to select MSP. And then once you select MSP on both of those sections, right in this area, you're going to hit save and reboot again, and then you should be good to go. You'll plug in, and you will be looking in this top bar up here, and if everything is good, then your flow and your sonar icons will be blue. We are indoors right now. It's hooked up to my computer, so obviously GPS is not going to be acting right or showing properly. And then we do not have a battery plugged in, so our GPS, our magnometer, is not going to be working properly. So that's why those are red. So don't be surprised if yours are red. But you do want the blue flow and sonar, and that is that will show that that is good. On Discord, so iNav has a Discord. I don't know if y'all do Discord, but it is a good resource and a good place to get support. This right here is actually the test quad that I built, and the question that I came up with I wanted to pass along is, so your drone is going to have a GPS, and if you've purchased this Lidar sensor, it's going to have that. And you can't have both at the same time, obviously. If you're indoors in a competition, you're wanting to use the Lidar optic flow, you're not going to be able to use your GPS. If you're outside and you want to be able to use your GPS, your optic flow sensor has a max of, I think it's 2 or 3 meters. It's basically like 6 feet. So I'm going to say that's 2 meters maybe. And above that altitude, it will no longer be accurate. So my question to the iNav group was, is there a way to make a switch to go between the two? A couple of people had some suggestions. You can, let's see, you could do a global function. So in the, let's see, do I still have my iNav? You could connect global variable. Here we go. So I'll have to do a follow-up on this to add it, because basically the workaround that I wound up going with is just disabling the GPS whenever I'm indoors. Let's see, so there was another suggestion. You can go into CLI, which is this here, and you can type in this here, set nav extra arming safety equals allow bypass. And what that does is, let's see, if safety set to allow bypass, the user is able to momentarily disable the navigation pre-flight checks. So iNav does a series of pre-flight checks when it wants to fly, and if any of those pre-flight checks fails, then it won't let you take off. So what this person was suggesting is to allow bypass, a momentary bypass, so that you can take off inside of a building, therefore bypassing the GPS fix. But again, the downside to that is if you forget to re-enable your GPS and you go outside and you go flying somewhere, your return to home may not work because you've disabled your GPS. So again, this is why I figured it was easier just to unclick or uncheck the GPS option so that I had a red indicator and so that I didn't have to worry about it. We can discuss with you how you want to handle it, but the thing that I'm trying to show is that when you're indoors, you won't be able to use your GPS. If you wanted to use the LiDAR sensor, you need to disable the GPS. Or you can do it by typing in CLI set nav extra arming safety equals allow bypass, and that will do the same thing. That just means that, again, if you're outside, you'll want your GPS. So don't take off, because it says it's a momentary option, so that means it should kick back in. So if you didn't take off, theoretically it would have kicked back in and you'd have your GPS. But again, like I said, if it was me, and since I'm passing this out to you guys, the easier way would be just to, here we'll go back, set up, connect, calibration, that's not it, it's configuration, here it is, GPS navigation and telemetry. So if you were to just to uncheck that, hit save and reboot, it would basically forget that you have a GPS, and you would be able to utilize the position hold and altitude hold of the LiDAR sensor. The only other thing that I am going to touch on, let's go to our YouTube site. What it is so the other challenge I ran into when I did our test build was I had some drift. I put it into position hold when I'm inside, and I would get a little bit of drift. Here it is, trim, ACC trim sticks. So
Alright,
we're not
so
exactly...
you guys had questions about using the accelerometer trim or ACC trim.
So basically,
It's got a really...
like I said, I had some drift. So when if you experience the same thing, just come to the Cobra Racer playlist and check out this stick trim commands video, and this should help with if you wind up with any sort of drift. And then one last thing I'm going to touch on, go back to our website, go to the PDF instructional manual. The other thing I wanted to touch on is the floor. So aligning, if you do put it on the Cobra, I'm going to hit one other thing, our Thingiverse site. If you do the Cobra, you're going to need some legs. If you do get this LiDAR sensor, I would suggest printing some legs. I can print them and send them to you, or you can download them from our Thingiverse website. But the LiDAR sensor needs Where is it? Thought I opened it. There, I'm opening it again. It's right here. So the LiDAR sensor needs a certain amount of height. Connected. We talked about the MSP. We talked about this, aligning the hardware. This I didn't have a problem with. I just put it centered of the quad. And so I don't think I had to do this step, but it is here if you wind up having problems. Calibration, so let's see, optics and variable flight modes. This is where it talks about position hold and altitude hold. Tuning here. Thought I had one about the floor. Because basically what it's looking at is it needs some kind of like pattern. Find a well lit terrain. Optic flow needs contrast, texture. It can observe to measure motion. It won't work on solid color, low contrast surface or in low light. Laser rangefinder needs a relatively reflective surface to work properly. It won't work over dark surfaces. Furry carpet is also not a very good example of terrain. So these are things you might want to take into account, at least on how well of a solution it is for your uses. But with that, I think I've covered everything. You need the height for the so that it can calibrate properly. If it drifts, we have a stick trim adjustment video you can check out. We have our manual online. We talked about how either you can add it or I can add it. So I think that covers about everything. If you have any questions, please email info@onpoint.com or call 833-667-6968, or you can comment below and or give suggestions. And thank you very much.